Thank you. I'm, I guess, not quite the last thing standing between you and beer, but I'm pretty darn close. So I appreciate you paying attention to me, and I appreciate you coming to Seattle, which is my hometown, and it's pretty exciting to be here. Actually, about 3 years to the day from when I started down this whole journey, so that's pretty amazing. So I wanted to start actually just by saying thanks, and that's really to Cole Mickens, who is from Microsoft, and Huamin Chen, who's from Red Hat, who really are the people who are responsible for Kubernetes on Azure so far. They have done a lot of the work, almost all of the heavy lifting in terms of supporting Azure as a platform, and I really appreciate that. It's great to see the community step up. It's great to see Red Hat step up. There have definitely been others as well, and so just because I'm not mentioning them, but these two I wanted to highlight in particular. All right, and so I wanted to talk a little bit about where we are. So with the release of Kubernetes 1.4.x, we really sort of ramped up the level of Azure support in Kubernetes. There's native Azure networking. There's support for Azure L4 load balancing. We have support for Azure Files, so that's SMB mounts into pods. And we're starting to have support for Azure Virtual Disk mount and unmount. That's definitely probably the most beta feature. And in particular, we don't support auto-provisioning, although that PR just merged, so it will be part of Kubernetes 1.5. So that's pretty exciting. But what's more exciting to me today is where we're going, which is, I don't know if those of you saw the announcements that went out this morning, but Kubernetes is now a part of Azure Container Service, which is one of the products that I'm responsible for inside of Azure. And so now creating Kubernetes on top of Azure is as easy as running Azure ACS create orchestrator type equals Kubernetes. There's a ... because you got to give it a resource group and a few other parameters. But it's a significant step in terms of making Kubernetes really an easy to use part of the Azure platform. It's also exciting because we are having a container registry, a private container registry. That is actually rolling out on November 14th, I believe, into public preview. So you'll have to wait about a week for that. Although Azure Container Service and Kubernetes, you can use right now the command line. Their drop of the command line tool is coming out on this Friday, I think. So that is going to contain the actual command line tooling. But it's up on GitHub right now if you want to live on the bleeding edge. All right, so that's a pretty exciting part of what we're doing. And I wanted to take a step there and actually give you a demo of what this experience looks like. So I'm going to drop out of here. That would be the full screen. I'm going to drop out of here. And I'm going to drop over to my, so what you can see here, I'll clear this. I was testing it ahead of time. Oh, silly. This is the display, not display mirroring. Let's see if we can do this. Sorry, this is the first time to. All right, cool. This is the first time presenting on this laptop, so you'll have to bear with me. All right, cool. Whoa, it's all wiggly. So here I am on the box, and I've actually created the cluster already, but the command that I ran there was ACS. You can see AZ, ACS create. My orchestrator type is Kubernetes. It's important to point out Azure Container Service actually supports all three of the most popular orchestrators that are out there, and just by changing orchestrator type, the same command could be used to create DCOS or Docker Swarm as well. We give it a resource group, the DNS prefix to identify the machines, and just give it a name, obviously. And so that created the cluster. And then I can actually run AZ get credentials here. And so what this is actually doing is it's going up onto the master node, and it's actually obtaining the credentials necessary. And now at this point, I can just run kube control get nodes, for example. And my Kubernetes cluster is up and available. It's been up for 4 hours, as you can see. I set it up earlier. It takes about 4 to 5 minutes to turn up a cluster, just in terms of provisioning things. But if anyone set up Kubernetes, has anyone set up Kubernetes out there or OpenShift out there? Is this easier or harder than when you did it? Easier? I hope so. I hope it's easier. I mean, if you're not, maybe not. I actually was putting together my Raspberry Pi cluster last night, and it was definitely harder. Although I was using the kubeadmin stuff, which is pretty cool and actually makes it pretty straightforward. OK, so we'll drop back into the presentation here. All right, give you a flavor for that. So that gives you a flavor for some of the experience that we're trying to build around both the integration of creating a cluster as well as the integration of the tooling experience. So you can really easily, anywhere where you have the Azure command line tool that's running, you're going to be able to get the credentials for your cluster. Immediately, kube control starts to work. There's actually a command there as well to download kube control for Windows or for Mac OS X or for Linux. So really a one-stop shop for integrating your experience. And we'll do more going forward. We've already sort of been proof of concepting out integrations with Azure Active Directory for authentication, as well as other pieces that sort of make it a more full-fledged citizen within the Azure environment. All right, so this is where we're going. We have disk provisioning in progress. As I said, that's out for pull request. There's an ingress provider for Azure application gateways that's available. You can actually use this right now. The only reason I say it's for 1.5 is it's still very much alpha. It's done by another person who's an interested person on the Azure, one of the Azure teams that just took a look at it, was interested, knew about the application gateway APIs, was interested in helping out with Kubernetes, and built the HTTP load balancer. And as I mentioned, we're doing AAD integration via OpenID Connect. We're going to do, I think going forward, right now we can use OpenID Connect for authentication. We want to do better integration so you can have seamless RBAC and policy that flows between Azure and Kubernetes. And then finally, this has been a request in general, I think, for Kubernetes, and as a community, I think that we need to start taking this as something we want to consider. Secrets exist as an API object, but right now they're backed out only into the etcd store. We need to start, in many other places we're very pluggable, and in the case of secrets, we're not. And so we need to really start figuring out how are we going, and as these platforms, Azure has its own built-in secret store. As these platforms start building in secret stores, we need those things to be pluggable just like load balancers, just like disks and everything else. So that's something that I think as a community we need to figure out. All right, but I wanted to move a little bit, because it's kind of boring, honestly, for me to come through here and talk to you about, like, we added load balancer support, blah, blah, blah. So I wanted to talk a little bit more about the stuff that surrounds the cloud provider, the stuff that surrounds Kubernetes, and what really the developer cares about. Because at some level, creating a cluster is something that you're not going to do a lot. You're going to do it once, and then you're going to hopefully use it for a very long time. Or if you are doing it a lot, it's part of some sort of automation that is running unattended. And so I wanted to talk about sort of some of the tools that Microsoft has been putting out there. Visual Studio Code was open sourced in April 2015. We just recently, I don't know how many people saw the announcement, we've open sourced PowerShell in August of 2016. And then moving forward with Azure Container Service, we've started open sourcing something that we're calling Azure Container Service Engine. And so really the idea here is, as we sort of talk to a lot of different community members, and you may very well have been part of this, we found that there's a bunch of different people who've been trying to figure out how they should turn up container orchestrators inside of a cloud platform. And there's lots of different templates and lots of different infrastructure for doing this. And they're all just slightly different. And because of that, it's very hard to share knowledge. It's very hard to have a common sort of set of best practices. Someone can figure out something, but it only goes into their templates. It doesn't go into the other templates that someone else uses. And so in creating ACS Engine, we really wanted to create a place where we could all come together and talk about what are the best practices for running container orchestrators on Azure in general, right? And do that in an open way, in an open community. And have real community-driven collaboration on these features and enhancements so that we can take the best practices that people are building out there and we can integrate them so that everybody can use them. And if they're popular enough, eventually they'll become part of the Azure Container Service product itself, right? I think there's always been a little bit of a tension between people who come into container service and they really like the ease of use and the manageability, but they're like, well, but what about this one special little thing that I need over here? And then at that point, the team has to say, like, is this a general purpose feature or is this a feature for you? And we didn't really give a good path for those things to become part of a community-supported solution. And now, hopefully, with ACS Engine, we're really going to be in that place. So basically, what it is it's an Azure Container Service that happens to run on your machine. So it's not the API surface. It's actually just a binary. You can give it a little JSON blob that looks just like the JSON blob that you would give to the Azure Container Service API. You run it through the Azure Container Service Engine. It turns it into an Azure Resource Manager template. And then that template is deployed to the cloud, right? So you're not really, it doesn't, obviously, we can't give you the same SLAs, and we're not going to be able to, as we go forward, be able to do upgrades and manage the things for you. But it enables you to customize and adapt things to fit your needs, even if Azure Container Service doesn't quite match those needs. At least you can share in most of the benefits of what we put into those templates and the curation that we put into those templates. So there's documentation here about how to use Azure Containers ACS Engine to turn up Kubernetes. And we really encourage anybody who's out there, whether you're interested in Azure Container Service or you're just turning up OpenShift and Kubernetes for yourselves, to come and collaborate there and help us improve those templates. It's hopefully going to turn into really a place where we can share a lot of knowledge. All right. And then the last piece that I wanted to talk about was something that I've also been really playing around with lately, and that's this idea that we really need to integrate development and deployment. And I think it's probably, for people who are used to using OpenShift, this is probably sort of natural, because OpenShift brings a lot of deployment and development pieces together. It builds images for you, deploys images and things like that. But I really think that in some ways, we haven't done enough work to connect the experience of the developer tightly in with the experience of the deployed software. And so I've been using Visual Studio Code lately, which has become sort of my default editor of choice. I've been playing around with figuring out how we can take the experience of developing an application for Kubernetes and the Kubernetes APIs themselves and really produce sort of an integrated experience. And so I'd like to give you some of the ideas there. And one of these ideas is that if I'm editing a Kubernetes API object, right, I should be able, I'm contextualized, right? My editor knows where I am. It should be able to very easily, with a couple of clicks, give me information about that object out in the cloud. What's the information? What's going on with it? How many replicas do I have? What's its health status? All of this sort of thing, right? The fact that I'm in this editor contextualizes me towards the application that I should be looking at in the cloud. Likewise, I should be able to pull things out of the cloud back into my editor, right? If I want to, and you can already sort of do this with kubectl edit, but I really want to be able to say, like, you know what, I have this thing out there. I want to make some changes to it. Can I pull it down into my editor so that I can do that sort of thing? So it's a bi-directional sort of integration of both development and deployment. Likewise, I'm in a particular object. I want to know what its logs are, right? I'm looking at this thing. I'm editing this, and I want to understand, how's it actually running out there? And I also want to go from my function and just run it, right? I just want to go run this code out in the cloud somewhere. And finally, given some code that happens to be running out in the cloud, I'd like to sync my repository back to where that image is, right? Because the image that you've deployed out in the cloud, it's not running the same version of code that is in your Git repo right now, most likely, right? You've moved on from the thing that you deployed. Even if it only deployed an hour ago, you've moved on from where it deployed. But if you're debugging it suddenly, if there's weird log messages or your pager went off, it'd be really handy if you could say, like, hey, this application out there contextualized in my Kubernetes provider, could you sync my whole repository back to where that image is? And if we follow some simple best practices around things like tag your image with the Git hash, it's very easy to build these kinds of integrations. All right. So I wanted to give you a demo of this, and hopefully it'll work. This is always the fingers crossed moment, I guess, or you guys are all here to see blood in the water, I think, right? So actually, you're hoping it doesn't work, but I'm going to hope that it is. It got to end the day on a live demo, right? Absolutely. So this is running on a computer that's sitting on top of my washing machine right now. Oh, can I make that bigger? Yes, maybe. Zoom in. Let's see if that does. All right, how's that? A little better. Can you make your screens bigger? No. All right, let's try zooming in again. And this is not very exciting. This is a very simple Node.js application, but now at least you can sort of read it, maybe, hopefully. All right, cool. This is actually running on a machine that is running on top of my washing machine right now, and I said to my family, please don't unplug this, so I'm hoping that they don't. All right, so which shows you how living dangerous I am. All right, so I have a very simple Node.js application here, and so of course the very first thing that I want to do, being a good container developer that I am, I'm going to build this out into an image, and because I've zoomed in, now my window here is giant. So I'm going to go into my terminal, and I say docker, and now it's, all right, docker build -t. Oh, actually, cancel. I need to first say git describe. Get my current git hash. All right, there's my git hash. You're going to see how bad I am at typing. All right, docker build -t. Oh, yes, well, All right, so let's build that image. All right. I did this before, so it happens really quickly. And we're going to push that. All right, so again, it's already out there, so it should be pretty fast. All right, so there we go. We've done our Docker build here, but I'm in my application here, and I say like, well, I would really like to just see this out and running. All right, so I'm going to go Kubernetes run. No! See, blood in the water, I'm telling you. I'm going to live debug this, do you think? Do you think that's a good idea? Yeah. Wow, you guys are... I'm actually not going to be here for beer, as it turns out, sadly. It's hometown, so I got to go home. All right, let's see why this failed. So this involves quitting this. This is really going to go south in a hurry, because this is going to involve me loading up the code for the extension and then running it. And yeah, this is going to go south. I have a video. It worked in the video. We could all just watch the video. All right, there's, no, I need to be, sorry, that's the wrong one. This is really going to go bad. Sigh. This is good, though, because I have a very demo-rich environment for my talk tomorrow at KubeCon. And so, if I totally die here, it will mean that my one there will go great, right? 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 That's the way it works, right? Yeah. All right, let's try this again. Close. Please run. All right, now we'll go over here. This is what I was hoping for. See, why is there? That does not make any sense. Let's see if this works. I'm going to have to pull the trigger on this. I'm just thinking this is not going to happen, I'm afraid. It's time for the video. All right, I'm sorry about that. I'm going to have to go over here. No, you don't. It's true, you don't, but that's okay. That's dangerous, loading up all the videos I've uploaded on YouTube. No, actually, it's not true. It's not that dangerous. All right, here we go. I promise this did really work. So we should turn off the sound, though. All right, so we did this. Can you see that, sort of? All right, so we went in, and we're going to build that application. Let's see where I go. All right, let's jump forward to where we were. We'll just go through this. I'm rebuilding the application. Really kicking myself that this didn't work. All right, so there's the application built, and I could just this is the dream actually that I had to do like electronic dance music. They don't do anything, so I just be like behind here typing. Pretty awesome, right? All right, so we've pushed it up, and now we can actually run this application by hitting Kubernetes run. It's really a good demo. It's very sad that it didn't work. All right, so at this point, what it does is it creates a deployment. All right, so the simple node is deployment. That's what you should have seen. It's not what you saw. After the deployment's been created, now I can actually say Kubernetes load to find out, or I can say Kubernetes describe to find out more about this. So I can actually say Kubernetes describe, and I can't even spell even when I'm doing a video capture. It says, what do you want to do? I can describe the deployments, right? And then there's the deployment information that's been loaded up here, right? So I've integrated into the output information about the application that I've just described. I've got one container up there. It's running. Well, I actually want to maybe do some editing of this application. So I can actually say Kubernetes load, and it's going to load the deployments, and it's going to load that JSON file into an editor. So now I have that JSON object available in the editor, and now I can actually say, well, this is kind of a complicated Kubernetes object. I'd really like to understand more about it. I can actually turn on explanation mode. So I can actually say Kubernetes explain. And at this point, the explanation API has been activated. And now whenever I hover over something, it's going to show me what the information about that field is. So in this particular case, it gives me the description of the namespace. Right? So now I can go ahead and say, well, what do I like to do? Well, I'm going to scale up my application. Go to replicas, scale up to 3 replicas. And now I can actually say, OK, let's apply that. So now I can actually say Kubernetes apply. And it's been reconfigured. And if I do the describe again, what we'll see here is that it's available. And there's 3 replicas, obviously, sitting there. All right. So that's great. It's nice that I can manipulate my environment this way and deploy my application. But it's really more interesting if I'm available to actually or to show this application to the world. And so now actually I can go in and say, I can actually create a load balancer to match up with this by saying Kubernetes deploy, Kubernetes expose. So that's what I'm going to do right here. Kubernetes expose. All right. And I've exposed it. Now I've created a service to go and load balance across that application. And you'll notice, unlike before, I didn't actually have to type anything. And the reason I didn't type anything is because it was contextualized in that API object. And so now if I go to that load balancer, you can actually see, OK, here we go. The simple node proxy is there. And it's got that code that I was running, if I could do it correctly. There we go. So this is the simple code, this is that simple application that I was running. Now I can actually go into the editor, make a change to that code, make a change to the, or actually, first thing I'm going to do here is I'm going to load that service object in. And what you'll see when I load the service object in is that it set the port to port 8000. And the reason that it set the port to port 8000 is it's actually introspecting the Docker file that's in my integrated development environment to find that I've said expose port 8000 inside that Docker file. So it can make the link between my development environment and the thing that I want to deploy. So I'm loading up that service right here. And there's port 8000, just like it was in the Docker file. All right. And so now I'm going to commit, showing you that it's in the Docker file. It's the port 8000. And it's parsed the Docker file in order to figure that out. All right. So now I'm going to commit these to Git, the configuration objects to Git, hopefully. I guess I was feeling slow that day. Should still do fake typing. All right, so I can commit those 2 things to Git, because of course I want my configuration objects in Git. All right, now I can go back over here and I can make changes to this code here. So I'll go and I'll say a really cool test. And I'll save that. Now I'll commit those changes, obviously go back to Git, commit those changes. Go back to my terminal window, and then I can rebuild that application. Get a new Git hash, obviously, because I've made some changes. So there's my new Git hash. And I'm going to make the new image, build it out with the new Git hash, again, so that I can have that contextualization. And then I'm going to roll it up. After it's built, I'll push it back up to the Docker Hub. Somehow it's more exciting when I'm typing than when I'm watching a video. I don't know why that is, because it's the exact same thing. All right. So there you go. It's pushed. And now I can actually go back into my deployment. Now that it's been pushed, I can go back into my deployment, grab that Git hash. I can go into the deployment, make the change in the deployment object down here to the new image, and then do another apply. So if I do here and I put that new image in, save it, do a Kubernetes apply via the IDE, it's going to do that rollout all the way for me. And I'm going to go back to the proxy, and you'll see that the changes that I just made are now, oh no, see, I had an error even in the video. I needed to change the resource version because it was copied from the old resource version. So if I delete the resource version and do a Kubernetes apply again, it gets changed. And it's been updated. And if I go back over to the web browser, I hit reload, and the new test is there and available, right? And so I'm going to pause that there. come back over here and say, I really hope that that gives you an idea. I'll go back into presentation mode. I really hope that gives you an idea about how we should maybe think about integrating the deployment experience inside the IDE. And, oh, that's the wrong slide. All right, so there's the code that you can find it. Clearly, it has bugs, so I would recommend going and fixing it. Or file an issue, and maybe I'll get to fixing it. And I hope that gives you an idea about how we can integrate sort of the development environment as well as the production deployment environment in a way that makes sort of both a little bit easier to deal with. I wanted to end with also some links out there for running Origin and OpenShift Container Platform out on Azure. These are links to some quick start templates that can get you started with OpenShift Origin or OpenShift Container Platform. Harold Wang is around. He's in the audience somewhere, hopefully. He's back over there, and he's Harold Wang, sorry. Did I misspell that? Oh, dang it. All right. I can live edit that. I think I can at least live edit. There we go. Sorry about that. The links are blue, and when I pasted them in, they were very hard to see. So that can get you started with Azure and OpenShift, and that's it. So I appreciate your patience as I stumbled my way through that presentation. And I hope to see you tomorrow and the rest of the way through KubeCon. So thanks. You know, I would really love to add that, actually. I don't, it's not in there, but it's high on the question was, can you also debug? And I know exactly how to do it, but I haven't actually built it yet. So, but I think it would be super cool. So Visual Studio Code has this very simple standard in, standard out debugger interface. And you basically need to wire that up to kubectl run with, or kubectl attach to get onto the debug interface. So yeah, I think it's very, very doable, but it hasn't been done.
For Node.js, it seems to be OK, but what about the compiled languages?
For compiled languages? Well, so for compiled languages, you'd have to have another a compile step in there, right? Before you build the image, you'd have to. Do you mean for debugging, or do you mean for this kind of? Oh, for debugging, actually, no. I mean, you can launch a compiled application. I mean, it depends on the compiled application, but you know, like Java has the debug port that you can attach to, right? So you can funnel that through a WebSocket. Or like GDB, you can launch GDB in a streamed standard I/O mode that for a C++ binary or something like that. So I think it should work, actually.
Cool.
Yeah.
So congratulations on the big announcement this morning supporting Kube on Microsoft Azure. I kid you not, I've had 6 people come up to me and ask me, does this mean Microsoft is going to fund getting Kube to natively support Windows containers, either through the Docker API?
You should come to our booth tomorrow.
OK. Does that mean yes, or?
I don't know if you've seen the Apprenda demo.
Yeah.
But we have also been doing some work making on getting it up and running. I mean, I should really say, you said Microsoft funding. I should really say Apprenda has done most of the work here, right? So I don't want to claim any of the credit, but we have helped them connect a few lines and talk to some Windows networking internals people to sort of simplify things a little bit. And I think, hopefully, fingers crossed, we'll have the ability to have a little bit of a demo of that tomorrow at the Microsoft booth.
Great.
So,
thanks.
And certainly, it's something that we're interested in. Correct, Windows Server 2016 supports, and running Windows applications, right? Not running Linux applications, running Windows applications. Yeah, .NET. Yeah, no, that's what I was saying. That's.
So is Kubernetes running Windows containers on Windows Server?
Correct, yes. Although the master components still run in Linux.
Any chance for old Windows applications? Because there is this huge number of old applications, pre-2006.
Right.
And people need to rewrite them.
I will have to admit that I do not know enough about Windows compatibility to know if they would run on Windows 2016. But if they run on Windows 2016, they will run inside a Windows container. But I don't know enough about, like, in general, my experience is Microsoft bends over backwards to make things backward compatible, and so I would think that they would work, but I don't know for sure. Yeah, like Win32 particular, like if it's a 32-bit binary, that I'm not as sure about. But again, this is an area that I'm not very familiar with.
Other questions?
Quick question. So can you also scale up and down the cluster on Azure from command line also?
The command line support for scaling up currently works, but not for scaling down, for Kubernetes clusters. So you can scale down DCOS clusters. We need to work on the scale down part for Kubernetes
So the
clusters.
scale
I
up
should say
actually
the Kubernetes support is in preview, so there's definitely some features that we need to flesh out fully.
So you can spawn up a new node, add to the cluster from Azure directly?
Right.
Okay.
Yes, and with GUI integrations coming soon. So.
Any other questions? All right, well, thank you, Brendan.
Cool. Thank you very much. I'll see you around.